Okay, so we are the Group 10 from BSME 4A, Bujungan, Duabis, Legazpi, and Polinar. My name is James Mer Polinar, and our group are here to talk about energy storage systems, and I am going to be specifically talking about battery energy storage system. So, first, what are energy storage systems? Energy storage systems play a crucial role in modern energy management. They're designed to store excess electrical energy when it is available and release it when needed, helping to maintain a stable and reliable power supply. Energy storage systems are vital for integrating renewable energy sources into the grid, improving grid resilience, and optimizing energy usage. What purpose does energy storage systems serve? First is load balancing. Energy demand fluctuates throughout the day, with peak demand typically occurring during the late afternoon or early evening. Energy storage system can help balance this load by storing excess energy when demand is low and releasing it when demand is high. This load leveling helps prevent blackouts, reduce strain on power infrastructure, and minimize the need for expensive peaker plants that only operate during high demand periods. So this basically talks about how energy storage systems serve as a backup and is necessary when peak demand is in operation. Next purpose is renewable energy integration. Renewable energy sources like solar and wind are intermittent, depending on weather conditions. Energy storage system plays a critical role in smoothing out the variability of these sources by storing surplus energy when they generate more than is needed and providing it when their output is insufficient. This integration makes renewable energy more reliable and reduces the reliance on fossil fuels. So this basically talks about how energy storage systems is typically paired with solar or wind power plants. And when those solar and wind power plants are in operation, they store the excess energy. And when those solar power plants cannot operate on max um, capacity, energy storage systems comes into play and provides the necessary energy to the infrastructures. Next is grid stability. Energy storage system can respond almost instantly to fluctuations in voltage and frequency, contributing to grid stability. They can provide grid support services such as frequency regulation and voltage control. When the grid experiences sudden disturbance or outages, energy storage system can bridge the gap by injecting power, helping to avoid widespread blackouts. So as you can see, uh, energy storage system provide grid support services, and they are necessary when there is a blackout so that our society can avoid widespread blackouts. So backup power. Energy storage system can serve as backup power sources during emergencies or power outages. In residential and commercial settings, backup batteries ensure that critical systems like medical equipment, communication infrastructure, and essential appliances continue to function, enhancing reliance and safety. So battery energy storage systems or energy storage systems in general actually play a large part in our society, especially when power plants cannot deliver the demand of energy that our society needs. For example, in medical equipments or in hospitals and in communication infrastructures, it is necessary to have electricity so that those medical instruments and storage of communication devices can continue to run and function and support us in our daily lives. Peak demand reduction. Peak demand is a major driver of electricity cost and the need for additional power generation capacity. Energy storage system can reduce peak demand by discharging stored energy during high demand periods, effectively shaving the peak load. This not only lowers electricity bills but also reduces the environmental impact by minimizing the use of fossil fuel based peaker plants. So, peak demand reduction by e- energy storage systems means that when our the need is high or our society is at peak demand, the corresponding power plant needs to deliver uh, more energy, meaning they have high costs in operating the power plant just to reach that maximum demand. But with energy storage systems, we can shave off those peak loads so that the power plants no longer need to operate at high demand and expend more resources, and this this effectively reduces our electricity costs. So next is battery energy storage system. So this is my subtopic. So battery energy storage systems are a subset of energy storage system that uses chemical reactions to store and release electrical energy. They are widely used due to their efficiency, scalability, and rapid response capabilities. So in the word battery itself, it uses chemical reactions. So battery uses chemical reactions. The lithium ion battery is an example. So this is a picture of a station of battery energy storage systems. So there are battery energy storage units like this cube, cubic or rectangular prism shape uh, devices. Components of a battery energy storage system. So it is shown here what composes a battery energy storage system. The storage device and with the monitors and control. There's a DC switch. There's a temperature control which is important to regulate the temperature of battery energy storage systems. There's a power conversion system, an AC breaker, and an AC transformer. Because battery energy storage system stores electricity in a form of DC or direct current, and so for it to be used, we need to convert it into an AC. So that's why there is a power conversion system. So first component, battery cells, of course. At the core of battery energy storage system are individual battery cells, which contain chemical compounds that store energy. The most common type of battery used in battery energy storage system is the lithium-ion battery due to its high energy density and efficiency. But other types like lead acid and flow batteries are also used in specific applications. There is battery management system. The BMS monitors and manages the performance of each battery cell within the system. It ensures that the batteries are charged and discharged safely, prevents overcharging or overdischarging, and optimizes the overall health and efficiency of the battery pack. So next are the inverters. BESS typically includes power inverters that convert the direct current stored in the batteries into alternating current, which is suitable for use in homes, businesses, or the electrical grid. So I talked about this here previously. Next is cooling and thermal management. Battery cells generate heat during charging and discharging. Of course, proper cooling and thermal management systems are crucial to maintain the batteries at optimal temperatures, which improves their lifespan and safety. So next is how does a battery energy storage system work? First is charging. During charging, electricity from an external source such as a solar panel, wind turbine, or the grid is used to send a current to the battery cells. This current forces a chemical reaction that stores electrical energy within the battery in the form of a chemical potential energy. The battery cells absorb and store this energy. Next, the energy is stored within the battery cells until it is needed. The stored energy can be used later for various purposes, such as providing electricity during periods of high demand or when renewable energy sources are not generating power. Discharging. When electricity is required, the battery system inverters convert the stored DC energy back into AC, making it available for use in electrical devices, buildings, or the grid. These processes release the stored energy and powers connected loads. So before we talk about the applications of a battery energy storage system, I have a video that will explain or put into detail more how does battery energy storage system works. So as you can see, this video is from Modo, and I only downloaded it. So we can see here the units of battery energy storage systems on a station. And as I talked about earlier, battery energy storage system don't actually generate electricity. They only store those electricity that they got from the power plants or the grid. Okay, so they charge, and then they store those energy and discharge it for later use onto back to the power grid and to the infrastructures. So it is illustrated here that um, battery energy storage systems import energy at lowest possible price and export at highest possible price, which means that they profit through this kind of trade. So when when power plants are producing energy at excess, so that's when electricity is at its lowest possible price. Battery energy storage system store those electricity, and when the demands of society is at peak or high, and the power plants have difficulty delivering those, and the battery energy storage system can be put into play, and they sell those energy at price and they profit. So I talked about this earlier, and the power plants are not necessarily at their peak capacity all the time. So battery energy storage system store those energy excess energy when the power plants are at peak capacity, and when the power plants cannot function at the peak capacity, like solar power plants not having sufficient solar energy, the battery energy storage systems can be put into play. So this here is what you can what is delivered by battery energy storage systems. So there is a rated power, an energy capacity, and a duration. So rated power is the maximum power uh, a battery energy storage system can charge or discharge. So it is like the capacity of a battery energy storage system, and this is measured in megawatts. So the energy capacity means that this is the maximum amount of energy battery energy storage system can hold. So rated power is is the megawatts of a battery energy storage system, and the energy capacity is what a battery energy storage system can hold. And the last part is the duration. Duration simply means the length of time that a battery energy storage system can provide maximum output to a community. So to better understand this rated power, energy capacity, and duration of a battery energy storage system, if a battery energy storage system has a rated power of 10 megawatts and it has an energy capacity of 10 megawatts, then it just means that that particular battery energy storage system uh, can have a maximum output of 10 megawatts for 1 hour to the community that needs the battery energy storage system. And when the energy capacity is at 20 megawatt hour, then it can discharge a rated power of 10 megawatts at a duration of 2 hours. So that's just the gist of these three categories of a battery energy storage system. So going back into the PowerPoint, we're going to be talking about the applications of a battery energy storage system. Renewable energy integration, energy capture. BESS is often paired with renewable energy sources like solar panels or wind turbines. When these sources generate more electricity than it is currently needed, the excess energy is sent to the battery system for storage. And then energy discharge during periods when renewable sources are not generating electricity, the stored energy in the BESS is discharged to meet demand, ensuring a consistent and reliable power supply. So load shifting. So I talked about this on energy storage system in general. Peak load shaving. BESS can be programmed to discharge stored energy during peak demand periods, such as hot summer afternoons when air conditioning use is high. This helps reduce electricity consumption during expensive peak rate hours, saving money or utility bills. Off-peak charging. During off-peak hours when electricity rates are lower, the BESS can be charged, storing energy for later use. This practice takes advantage of lower electricity prices and maximizes cost savings. So this is talked about in the video. So next is grid support. Frequency regulation. BESS can respond rapidly within milliseconds to fluctuations in grid frequency. When the grid frequency deviates from the desired level, the BESS can inject or absorb power to help stabilize it. This is crucial for maintaining grid stability and quality. Voltage support. In addition to frequency regulation, BESS can provide voltage support by injecting or absorbing power as needed to maintain optimal voltage levels on the grid. So voltage support, BESS is actually playing a crucial role in maintaining our grid lines when it is connected to it. Backup power. Emergency power supply. BESS can provide backup power during power outages when the main grid fails. The BESS automatically switches to supply electricity to critical loads, ensuring uninterrupted operation of essential equipment and systems. Seamless transition. The transition from grid power to battery backup is typically seamless, with no interruption in power supply, making it valuable for critical facilities like hospitals, data centers, and emergency response centers. Peak demand reduction. Load leveling. BESS can flatten out the peaks in electricity consumption by releasing stored energy during periods of high demand. This reduces the need for additional power generation capacity and lowers electricity costs. Demand response. In response to signals from utilities, BESS can quickly reduce electricity demand by discharging energy, helping utilities manage their grid more efficiently. Microgrids. Localized energy supply. In microgrids, BESS can provide localized energy storage and supply, allowing the microgrid to operate independently of the main grid when necessary. This is particularly valuable in remote or critical facilities where reliability is essential. Grid resilience. BESS can enhance the resilience of microgrids during grid disturbances or outages, ensuring continuous power supply to critical loads. So, BESS actually plays the supply in microgrids. So there is places here in Bohol that are not really connected to the national grid. So they are only powered through microgrids, and BESS can provide the localized energy for that particular place. So first, let's summarize the battery energy storage system or the energy storage system in general. So, battery energy storage system is a vital technology that plays a key role in energy management and also in grid stability and the integration of renewable energy sources into our electrical systems. It stores electrical energy efficiently and can release it when needed, making it a versatile tool in modern energy infrastructure. And in each of those applications of the BESS, the fundamental principle of a BESS remains the same. It stores electrical energy in its batteries when it's abundant or inexpensive and releases it when needed. And thus, it provides flexibility and efficiency in managing electricity supply and demand. The specific operation and control of a BESS depend on the application and the goals of the system operator or owner. So let's talk about the battery energy storage systems in here in the Philippines. San Miguel Corporation nationwide BESS network with a combined capacity of 1,000 megawatt hour. It is part of the total 32 battery storage stations being built by SMC through its San Miguel Global Power or SMGP all over the country. The first and largest such network in the country and among the largest integrated battery storage networks in the world. The project is part of SMC and SMGP's aggressive and medium-term goal for power system decarbonization and resilience. With a total of 1,000 megawatt-hour of BESS in 32 sites nationwide, San Miguel Global Power, a proudly Filipino company, is poised to become one of the largest grid battery storage system operators in the world. So this is pretty large a network of the San Miguel Global Power. 32 sites nationwide, meaning 32 stations nationwide with a total of 1,000 megawatt hour. So this can provide the necessary power when the power plants are not in the maximum operation or maximum capacity. So this is an image of one of the SMGP's best stations. So we can see what really battery energy storage systems are looking like. And so this ends my part of the reporting, and I will hand over the presentation to the next reporter. Thank you.
Energy storage systems play a pivotal role in modern energy infrastructure. Among these, compressed air energy storage stands out as a promising solution. This report delves into the various types of case and their applications. So the basic principle. Compressed air energy storage is a method of storing energy generated at one time for use at a later time. It operates on the principle of compressing air using excess energy and then expanding it to generate electricity when demand is high. So the types. First is the diabatic. Diabatic compressed air system is a type that does not attempt to maintain constant temperature during compression and expansion. Instead, it exchanges heat with the surroundings. While this can lead to some energy loss, it allows for simpler and potentially more cost-effective systems. One example is the Hunter-Case power plant in Germany. It's an iconic diabatic facility. It operates by compressing air using excess electricity, storing it in underground caverns, and then releasing it to generate electricity when needed. During the expansion phase, natural gas is used to reheat the air, which increases its efficiency. The second type is the adiabatic. Adiabatic compressed air energy system aims to maintain constant temperature during compression and expansion by incorporating thermal storage. This type can achieve higher efficiencies, making it an attractive option for large-scale energy storage. One example is the Adele project in Germany. It's an adiabatic system. It incorporates a thermal store, which allows it to maintain constant temperature during compression and expansion. This results in higher efficiency compared to the diabatic case systems. The third one is the isothermal. Isothermal compressed air energy system maintains constant temperature by using intercoolers and reheaters. This type strikes a balance between the complexities of adiabatic and case and potential energy losses in the diabatic case. One example is the Iowa Stored Energy Park. It's an isothermal case project located in the United States. This type of case system uses intercoolers and reheaters to maintain constant temperature. ICEP uses a porous rock formation to store the compressed air, allowing it to operate at near constant temperature levels. So the comparison of those types. Diabatic systems are generally simpler and more cost-effective to implement. Adiabatic, while more complex, offers higher efficiency and better adaptability to various operating conditions. Isothermal balances both factors, making it a viable option for certain applications.
So hello everyone, I'm Jessamine Duaves, and today we will explore the pump hydro storage, so often abbreviated as PHS. So this is a fascinating type of hydroelectric energy storage. So the PHS operates by harnessing the gravitational potential energy of water and is a key player in the world of energy storage. So let's dive right in. So what is pump hydro storage? So the pump hydro storage or the pump storage hydropower (PSH) is a method of storing and releasing energy using the gravitational potential energy of water. So it consists of two water reservoirs situated at different elevations. So to further understand what is uh, pump storage hydropower and to see how this looks like, how this operates, so let's watch a video. So next, how does it work? So during periods of excess energy, PHS systems pump water from the lower reservoir to the upper one, storing potential energy. So when the energy is needed, water flows back down, passing through a turbine and generating electricity. So let's watch a video on how this PHS system works.
Wind power can only be generated when the wind is blowing, and variations are considerable over time. These variations do not always correspond with the consumption. A large share of wind power would represent a major challenge to the stability of the transmission systems and the security of supply for the consumers. There is a need for backup capacity in order to generate power on days with no wind and high demand. There is also a need for storage capacity for surplus power on days with strong wind and low demand. In Norway, with its long history of hydropower generation, we find half of Europe's reservoir capacity. New pumped storage power plants in connection with existing reservoirs could be part of the solution in securing a reliable energy system. On windy days, surplus power could be used to pump water from low to high altitude reservoirs. This water could in turn be released to generate power on days when demand is high and wind levels are low. This cycle can be repeated over and over again. In order to use Norwegian hydropower reservoirs as rechargeable batteries for the European power supply, more transmission capacity must be established between Norway and the major European consumption areas. Pumped storage power solutions must be developed in such a way that the environmental impacts are reduced to a minimum. The climate threat is a global challenge. A further development of Norwegian hydropower can contribute to a more reliable and, not least, a cleaner European energy supply.
So for the history of the PHS, so the concept of PHS dates back to the 1890s, with its first known use in Italy and Switzerland. So the United States adopted PSH in the 1930s, and today, PHS facilities can be found across the globe. So in the US, PSH accounts for a remarkable 93% of all utility-scale energy storage. So Philippines did not have any large-scale pump hydro storage facilities in operation. So however, we have an ongoing pump storage project which is the Kalayaan Pump Storage. So the hydropower project consists of two turbines, each with 336 megawatts nameplate capacity. So the project has two electric generators that will be installed at the project site. So the project construction is expected to commence from 2029. So what are the advantages of PHS? So PHS boasts several advantages, including high efficiency, so often exceeding 80%. So rapid response time, long lifespan, often exceeding 50 years, capability for large-scale energy storage, and minimal emissions and pollution. So what is the current status of the PHS? So currently, there are 43 PSH plants in the United States. So there's potential to double the current PSH capacity, making it a dominant form of energy storage on the electric grid. So PHS also plays a vital role in integrating renewable resources. So there are system variations. We have the open loop and the closed loop PSH. So the PHS open loop PHS systems have a hydrologic connection to a natural body of water. So while closed loop PSH reservoirs are not connected to an outside body of water. So we can see from the figure from the uh, illustration the difference sa open loop and the closed loop. So despite its advantages, we have PHS does come with challenges, so including geography-dependent requirements, the high initial construction cost, and the environmental impact, such as ecosystem disruption. So, application of PHS. So, PHS finds applications in various areas, such as the grid stabilization and balancing, integration of renewable energy sources, peak shaving during high demand periods, and emergency power supply. So there are notable installations of the PSH. So first, we have two notable PHS installations. So first is the Dinner Wake Power Station at the Wales. So the capacity is 1.8 gigawatts. So 1,800,000,000 watts. So the world's fastest responding power plant. So next is the Bass County Pump Storage Station in USA. So the capacity is 3 gigawatts, so 3 billion watts. So this is the largest PHS facility globally. So looking ahead, PHS is poised for expansion due to the growth of renewable energy sources. So future developments will focus on enhancing efficiency and considering environmental factors. So to wrap up my report about pump hydro storage, uh, pump hydro storage is undeniably a reliable and efficiency energy storage solution. So it plays a pivotal role in the transition to a sustainable and clean energy future. So that is my report. Thank you.
So, good day to everyone, to Sir Orines, and to all of the classmates. So, now, I'm going to give you a summary in related to our topic that was given by Sir Orines. So, we only have the three topics in related to energy storage system. So we are 4 members of the group. So me as a last reporter, I am only going to summarize of what the previous members discussed, given the three topic, like first the battery energy storage system. Next is the pump hydro energy storage system, and the last one is the compressed air energy storage system. Actually, in the some countries, there are some energy storage system, including the energy storage system, the mechanical energy storage system, even the chemical energy storage system, the hydrogen energy storage system, the supercapacitors, the ultra capacitors energy storage system. So we are just going to focus in related to air, compressed air, the battery, and also the pumped hydro energy storage system. So for now, we are going to differentiate the difference of the three given topics to us. So first, the battery energy storage system. So battery energy storage system, as from the word itself, battery. So um, we the engineers um, store energy by the use of battery. So why we can store energy to the battery? Battery has a, it contains a, that's what we call the battery solutions. So later I will give you the I will show you some videos so that we can visualize what is battery solution is, and how can give us a um, idea why battery can really store some energies.
After the sun sets, and its production also varies. The motion of the sun, shading from adjacent trees and buildings, along with variable cloud cover, are major factors affecting solar electricity production. This results in wasted energy and lost revenue when supply is higher than demand, and power outages when demand is higher than supply. Grid operators are faced with the challenge of making a variable resource consistent, dependable, and predictable in order to meet customers' needs for electricity and optimize economic returns. Battery energy storage systems offer a way to do that. Here's how it works. Generation transforms energy into electricity. Transmission moves electricity from here to there. Battery storage moves electricity from now until later. Finally, end-use equipment transforms electricity into the services we really want. Lights on, beverages cold, water hot, phones charged. A battery holds electricity like a fuel tank holds gasoline. Each has a certain amount of capacity. The flow of gasoline from a tank to drive a car is like the flow of electricity from a battery to drive the electric grid. Each has a finite amount of capacity, so using it must be planned, budgeted, and controlled. Black & Veatch's preferred chemistry is lithium-ion, which is everywhere. Phones, computers, power tools, cars, trucks, drones. These batteries are the lightest in weight and smallest in size of any commercially available battery chemistry, which makes it the best option available today. Lithium iron phosphate is also the least prone to thermal runaway, which is when a battery short circuits, heats up, and can unfortunately catch fire. Unlike other lithium-ion batteries, when lithium iron phosphate is forced to short circuit, it remains cool and composed. When it comes to buying batteries, it can be a significant capital cost investment. In return, they also bring a lot of value. The cost of lithium-ion energy storage in terms of US dollar per kilowatt hour has fallen by over 80% in the last 10 years, with the expectation that the cost 10 years from now will be half of what it is today. This makes batteries more economically viable than ever, with returns on the investment faster than ever. Much of the value that batteries bring is in the many things they can do for the power grid that before now all required different types of equipment. Two of many examples include 1. Frequency regulation and frequency reserves, balancing the grid, making it stable and reliable. And 2. Arbitrage, saving electricity now when it isn't needed to be used later when it is needed. Now that you understand all the buzz about BESS, we're here to help you take the next step. Extensive experience engineering, procuring, and constructing power grid solutions, paired with our knowledge of control hardware and logic and software, uniquely positions Black & Veatch to deliver solutions that protect from outages and business interruption and capture the higher value of peak electricity, assisting you in meeting your sustainability, reliability, and resiliency.
So the next one is the compressed air. So by the use of the compressors, we can compress some air, and in the time that we are abundant of energy or electricity, that time we can use the compressor to collect or compress some of of the air, and going to expand or release when the time that there are warning of blackouts and burnouts, or the shortage of energy. So what happened is that the compressed air, and by the use of turbine with the generators, we can generate energy or electricity. So the next is the hydro pump energy storage system. So so from the like for example, there is dam, the lower dam and the upper dam. So in the middle, or a pump, that when there is an abundant of energy, water from a lower to the upper dam. So if there is some blackouts or burnout, water that is stored in the upper dam will be released on the time that needed. So water of upper dam will release, so there is a water turbine, and it can produce an energy. So how really important is the storing energy? By compressed air, the batteries, and the pumped hydro. So the three of that, there are ability to store excess energy during a period of abundance and release it if needed. Ensures a reliable power supply, reducing the risk of blackouts and enhancing grid resilience. Energy storage also plays a pivotal role in integrating renewable energy. Moreover, this system facilitates peak load management, cost and savings through the shifting of energy used, provided backup power during emergencies, and contribute significantly to the reduction of greenhouse gas emission. They represents a cornerstone in a transition towards the sustainable and decentralized and more reliable energy system, promising a greener and a more secure and efficient energy for the future. So that's all for this video presentation. I hope that you learned from what we have reported. Thank you to Sir Renes and to everyone. God bless.